Hey guys, welcome back to my channel. This is Varun. So in the previous session, we saw some useful techniques to create basic plots using matplotlib.pyplot and put some axis labels and titles on those. We also saw how to create multiple plots or subplots in the same figure and scaled x and y axes. Now we will continue our agenda from there onwards and create some common plots using market fact CSV dataset, which we used previously also during our Panda session, if you can recall. And then we will gradually move towards working with images as well. So let's start. Now, as we have seen earlier, we can draw various plots using Matplotlib and Seaborn. So the basics of visualization are taught in the earlier session, for which I will be giving the link in the description for you guys. If you have not seen that video, I would strongly recommend that you guys go there and first see that video. Okay, so now let's start. So we will first use this market fact CSV, which I have loaded inside this global sales data folder. Okay. Load this using read_CSV, and then we will try and plot these different plots. So let me first load the market fact dataset. So for that I will say pd.read_CSV and then give the path of that CSV, that is global sales data / market_fact.csv. Okay, and just to check if the records are coming here, I'm just printing initial 5 records here. Okay, so it's loading up. Now let's create several plots. Now let us use boxplot for quantifying different columns. So I'll be using continuous variable order quantity and sales for plotting the boxplot. So I'll say plt.boxplot df and give here order quantity. Okay, and when I say plt.show, this will be plotted. Now, as you guys have seen in my previous video, I have explained what boxplot means and what these different region means. I'll reiterate them for you. So this region, you can regard this as a minimum and maximum. This is the median, and this is the 75 percentile, and this is the 25 percentile. So you can see the median is lying between 20 to 30, and then the 25 percentile is lying between 10 and 20, and the 75 is lying between 30 and 40. Now let's check sales column. So instead of this, I'll just put sales. And here you might notice that box plot of this sales is pretty unreadable since sales varies across a wide range. Okay, so this is a kind of outliers it is showing here, and then the small box at the bottom, you can see this is the box plot which has the median, minimum, maximum, everything. So this shows that this has a lot of outliers in it, and thus this range or this scale is not sufficient for showing everything in a proper manner in this box plot. So we'll try and change the scale of the axis. So let's check the range of sales column first. So for that, as we have seen earlier also, we can use describe function. So this will give us mean, standard deviation, minimum, and various percentile and maximum of it. Okay, so we can see here that minimum is 2.24, median is 449, and maximum is 89061. So the solution to this problem is to change the scale of this axis as we have discussed before, so that the range can fit into the size of the plot. So one commonly used technique here is to transform an axis into logarithmic scale. So let's see how to do that. So I'll say plt.subplot. Okay, so I'm just comparing the two plots. So for that I am making the two subplots. So this will be the original plot 1 to 1 and plt.boxplot and then say df sales. Okay, and in the second subplot, that is plt.subplot, I will say 1 2 2 plt.boxplot df sales. Okay, here I will change the y scale, that is plt.y scale. I change this to log, okay, instead of usual numbers, and then say plt.show. Okay, now you will be seeing that this is the original plot that we had made before also, and this is the changed plot after changing the scale of y-axis. Okay, now it is fitting inside very properly, and we can even see the median, quartile ranges and the outliers, everything in the single plot. Now you can see here that clearly the log scale subplot is far more readable. So we can infer that minimum scale is around 0 here, and the median is approximately in the middle of 100 and 1000, and maximum is reaching 1 lakh. Now let us move to histograms. So histograms are useful for visualizing the distribution of a single variable. Now taking the example of sales, we will draw a histogram. So for histogram, we have to say plt.hist and then give df sales inside the brackets. Okay, and then I'll say plt.show. Okay, so you can see the distribution, but here also the same problem is there, that the scale is large and we are not able to fit every small scales or every small distributions into the same graph in a proper readable manner. So this can be made more readable by using the y scale, as we have seen in the case of this box plot also. Okay, so let's do that. So I'll say plt.hist. Okay, the same thing I'll copy here and just change the scale. So I'll say plt.yscale and give us log. Now you might have observed that this is more readable than the previous graph and the y scale is properly fit as log. Now let's move on to scatter plot. So scatter plots are used to visualize two variables, one on each axis. So we can take two different columns from our data set, let's say sales and profit, and let's visualize the two variables in the same plot. Okay, so I'll say plt dot scatter and give here sales column as x-axis and profit column as y-axis, and do plt dot show. Okay, so you might observe here that this is plotting a linear kind of relationship between the two. So you can say as sales increase, the profit also increase. Now let's see how do we read images using Matplotlib. So Matplotlib can also read images using plt.imread method. Internally, it reads and stores that image as an array, and that array can be used for various data manipulation tasks, just like as a normal array. So let's look at one of the example. So for this purpose, I have downloaded from internet one image that has a black and white 3 with background as white and the number written in black. Okay, so let's read this using Matplotlib. So I will say image equals to plt.imread and give the image name. Okay, that is number.png. So I'll say now plt.im show image, that will show us the image. Okay, so you can observe here it has plotted this with axis. Now let us look at some of the attributes of this. So I'll just print out some of the attributes like type. So this says that this is numpy array. Okay, and then let me print image dot shape. Okay, so just like array, it has shape, 3-dimensional shape, and then let's look at the d type of it. So I'll say image dot d type. So this is float 32. So note guys, this is a 3D array of size 679 into 900 into 4, and each element is stored as a type of float 32. Now let's look at the contents of this. So I'll just say image, and you can observe here that this is an array, and in this array each inner list of dimension equals to 3. It represents a pixel. So since this is an RGB image, there are 3 pixels other than the types of images in RGBA, where A is alpha and represents as transparency. Now we will not discuss images in detail in this module, though we will work with them later in some machine learning model exercises. Now I have some resources also for you guys to go through, as this will give you good hold over how various other plots are made. So when you click and go into this, you will be seeing that these are some official documentation that you can refer, and I will share these links in the description also for you guys. So this will be all for today. Thanks for watching, guys. Now in the next section, we will learn to visualize distribution using a different visualization library called as Seaborn. Until then, guys, please practice whatever is done in this session. Please also let me know in the comment section if you have any questions regarding any of the concepts, or you want me to share any resources or teach any particular topic. I will be happy to do that. Also, please subscribe my channel and hit the bell icon so that you are updated with my upcoming content on data science. Remember that this is the one-stop channel you can happily rely on for any content on data science. Please stay safe and take care of your loved ones. Thank you.